Okay, we're back talking about angles, and we just finished talking about reference angles and how to find the trig functions for any angle, how to find the y over r, the x over r, and that kind of stuff. So now we're going to move on to this thing, and you may have seen this before, you may not have. This is called a unit circle, and we're going to label it real quickly. And I want you to imagine that this vertical line and this horizontal line are an x and y axis. So this point right here is going to be the origin of an xy coordinate plane, and everything out here is a point that's in the xy coordinate plane. So this point right here is 1, 0. This point up at the top is 0, 1. This point over here is negative 1, 0. And this point down at the bottom is 0, negative 1. So we're going to try to relate degrees and radians in a way that will help you work with both. And the way we're going to do that is we're going to go around and label some specific degree measurements and then talk about what they really mean. So remember, we're thinking that this is our initial side of our angle. And so if this is the initial side, we're going to open up like this as we go around this circle all the way until we get back to 360 degrees. So when we start here, we're going to have 0 degrees. Then as our angle opens, this is going to be 30 degrees, 45 degrees, 60 degrees, and then up to 90 degrees. And the angles that we're talking about are the angles down here. So this angle, just for our drawing purposes, is 30 degrees. And then the next angle, 45, 60, 90. And we're going to go all the way around. So this is 90. Then we're going to start again and do 30 degrees more. So 90 plus 30 is 120. 90 plus 45 is 135. And 90 plus 60 is 150. And then ultimately 90 plus 90 is 180 degrees. So we're just going to keep going. 180 plus 30 is 210. 180 plus 45 is 225. And then 180 plus 60 is 240. All the way to 180 plus 90, which is 270. We're going to go one more time. So 270 plus 30, 300. 270 plus 60, 330. And 270 plus 270 plus 45, 345, and last one, 270 plus 60, 330, and if we finish going all the way around a circle, we would have gone 360 degrees. So that's how you need to be able to think about this circle and how these degree measurements fit on it. Now we're going to start with our radians. And radians are a little different, as you've learned already. But the way that we calculate radians is we take our degrees and we multiply them by pi over 180. So if we did 0 times pi over 180, well, that would still give us 0 radians. And we're not going to calculate each one of these. I'm just going to tell you what they are. So as we go up around the circle, 30 times pi over 180 is pi over 6. And here we have pi over 4, pi over 3, pi over 2. So now we're going to keep going from pi over 2. And it's probably a little tough to follow the first time you've ever seen it, but it'll make sense and be easy to remember if you think about it this way. So as we go to this next angle, 120 degrees, that's kind of, it's not kind of like, it is 60 degrees times 2. Well, pi over 3 is 60 degrees. So that times 2 is 2 pi thirds. And so like we talked yesterday or a little bit, if you know the 60, 45, and the 30 degree angles, you can really fill this thing out quick once you kind of learn the pattern. So 135 degrees, that's kind of like this 45 which is pi over 4, plus another 45, which makes pi over 2, because 1/4 plus another fourth is a half. So we're going to add one more fourth, one more pi over 4, and this will be 3 pi over 4. Okay, now 150 is 30 degrees 5 times. So 30 degrees is pi over 6. So 150 is 5 pi over 6. And then we get to 180 degrees, which is pi, because 90 degrees is pi over 2. So 2 of those is going to be 1 pi. And we're just going to keep going with this now. So 210 degrees, that's a 30 degrees times 7. So it's 7 pi over 6. 225 is 45 degrees times 5. So that's 5 pi over 4. 240 degrees is 60 degrees times 4. So 4 pi over 3. And then our 270 degrees is 1 pi half, 2 pi halves, 3 pi halves. And we're almost done. 300 degrees is 30 times 10, which is 10 pi over 6, and that reduces to 5 pi over 3. 345 degrees is 7 times 45, so that's 7 pi over 4. 330 degrees is 30 degrees times 11, so that's 11 pi over 6. Okay, and then 2 pi is 360 degrees. So that's how we can match up our radian measurements to our degree measurements. Now what we're going to talk about is the real heart of the unit circle and why we want to memorize this thing. Because you may have a problem that says, what's the sine of 30 degrees? Or what's the sine of pi over 6? And it's something that we need to commit to memory. And I'm only going to use the 30-degree angle to demonstrate it, but the rest of them all work the same. So on this 30-degree angle, you understand that to get to this point right here, we have an x value and a y value. We can see that the x value is definitely less than 1. And the y value is also less than 1. So you could calculate this by using the calculator and your trig functions, but it takes a while. So we're going to write them down and you're going to memorize them. So the cosine of 30 degrees or pi over 6 is the square root of 3 over 2, always. And the sine of 30 degrees or pi over 6 is always 1/2. So that means that this value right here, this distance, is the square root of 3 over 2. And this y value is 1/2. So my mark here is a little low. So this point right here is exactly 1/2 up this y-axis, because remember the sine and the cosine relate to the x and the y. So the x is the cosine and the y is the sine. And this distance right here, this hypotenuse of this right triangle, is the radius r, which in a unit circle always equals 1, because here we have 1, 0, and as we go up here to 0, 1, our radius is still 1, so all of these radius that we see here are 1. So we're going to go around and fill this in pretty fast, and your job is going to be to memorize it. You're going to have a quiz over it where you're going to have to reproduce a blank one. So when we get to 45 degrees and pi over 4, cosine is the square root of 2 over 2, and the sine is the square root of 2 over 2, which is nice because they're the same, so that's easy. And then when we get to 60 degrees and pi over 3, it's really nice that it's still the same values from 30 degrees, they're just flipped. So square root of 3 over 2, 1/2, square root of 2 over 2 are the only values you have to remember in here. As we go around to the other quadrants, we're going to find that all those same values appear. What you'll notice is something that you should already know. The cosines are negative over here in the second quadrant. Right? We learned that already. Maybe I should use these little bars as fraction bars. It might make this easier to write. Oh yeah, that's better, huh? And so hopefully you're filling this in along with me. And so we get down here in the third quadrant and we see that both of them, the sine and the cosine, are negative. Make our way around to the fourth quadrant, back to where the cosine is positive again, and the sine is negative. All right, so these values, these represent the sine and the cosine for all of these angle measurements in degrees and in radians. And our job is going to be to memorize this. Okay? And if you can make a connection between the 30-degree and the 210, you see that they have the exact same numbers in the exact same spot, except the signs are different based on what quadrant it's in. And then if you go up and look at 150, 5 pi over 6, it also has those same numbers. And if you follow that down right along this line to 11 pi over 6, or 330 degrees, it has the same numbers and the signs are different. All of these angles that match up like this, and you don't need to color on your sheet like this, you just need to see it. These are called bow tie angles. It's a way to remember which ones go together. So see how I've highlighted a little bow tie shape? Well, those are bow tie angles and they have the same values. Same works for the 135, the 225, the 345, and the 45. They all have the same values. So anyways, hope that wasn't too painful, and start memorizing it.